Hey everyone, welcome back to the channel Code with AKJ. Today is day 47 of solving Geeks for Geeks problem of the day. Today we are going to solve an interesting coding problem called single number. It's a popular problem and we'll go through two approaches first, a brute force solution and then an optimal solution using bitwise operations. So let's dive right in. So the question says here, given an array ARR of positive integers where every element appears even times except for one, find that number occurring an odd number of times. So we are given an array of positive integers where every element appears an even number of times except for one element which appears an odd number of times. So our task is to find that particular element. So given two examples here, the array contains values 1, 1, 2, 2, 2. Here we can observe that 1 appears 2 times and 2 appears 3 times, which is an odd number of times. So we return 2 in this case. So the second example here, the value contains 8, 8, 7, 7, 6, 6 and 1. Here we can observe that 8, 7 and 6 appears even number of times and 1 appears odd number of times. So we return 1 in this case. So they are expecting us to complete this problem in O of n time complexity and space complexity should be O of 1. So now let's jump into the solutions. So in our brute force approach, we can use a simple technique to count the frequency of each element. So the steps here would be to traverse over this particular array and count the occurrence of each element using a frequency map or a hash map. So once we have the frequency of each element, we'll check the element which occurs odd number of times and we'll return that particular element. So sounds simple, right? So let's code this approach. So let's take the size of an array. We'll use unordered map to store the frequency of each element. We'll iterate over the array. We'll store the frequency of each and every element. And now let's iterate over the map and let's check if the frequency of a particular element is odd. So if it is odd, we'll return that particular element. So if we didn't found after iterating over our map, then we can return -1 from here. So let's compile and run this to check if there are any errors. So there are no errors here. So let's submit. As you can see, this problem got solved successfully. Here the time complexity would be O of n as we are iterating over the array once, and the space complexity is O of n as we are using a data structure map. But here our expected space complexities should be O of 1. So we need to optimize this approach. So while this works, we can do even better. So let's see how. So to improve on space, we can use a bitwise XOR operation. This is a powerful trick that allows us to solve this problem in O of n time complexity and O of 1 time complexity. So let's see how. So generally the XOR operator has a few useful properties. So the first property is any number XORed with itself is 0. That is A XOR A gives us 0. And the second property is A XOR with 0 gives that particular number, which means any number XORed with 0 remains unchanged. And XOR is cumulative and associative, so the order in which we apply XOR does not matter. So here the third property is in XOR the order does not matter. So the approach here would be by XORing all the elements together, the pairs of even occurrences elements would be cancelled out to 0, leaving only the elements that occur an odd number of times. So for example here, if the elements are 2, 2, 1, 1 and 3. So if we XOR all the elements in this particular array A, so the numbers which are occurring in even number of times, it will cancel out to 0, leaving out only the odd number of times. So for example here, if we try to XOR 2 with 2, it will cancel out as 0 as this is our first property of the XOR. And same goes with 0 with 1. It remains unchanged, giving us 1. And then 1 XOR with 1 cancels out with 0. And finally 0 XOR with 3 remains unchanged, gives us value 3. So after XORing all the elements, we'll get our element which occurs odd number of times. So in this way, by XORing all the elements in our array, we'll get our required result. So in this case, our time complexity would be O of n as we are iterating over the array once, and space complexity will be O of 1 as we are not using any external data structure. So in this way, we have reached our problem using our expected time complexity and space complexity. So let's move on to the code now. So again, let's take the size of an array in the form of variable n. Let's take the XOR value result, which will be initially 0. We'll iterate over the array, XORing all elements together. And finally, we'll return that particular variable, which will store our expected result. So let's compile and run this. It's working, so let's submit. As you can see, this problem got accepted as well. But here, we have solved this particular problem in our expected time complexity and space complexity, which is O of n and O of 1. So this is it, guys, for this video. So in summary, in the brute force solution, we used a hash map to count occurrences of each element, which gave us a time complexity of O of n, but required extra space. So in the optimal solution, we leveraged the XOR bitwise operation to solve the problem in O of n time and O of 1 space. So I hope you found this explanation helpful. So if you did, make sure to give this video a thumbs up and subscribe to the channel for more such content. Thanks for watching, and I'll see you in the next one.